Hello. In this example, we're going to graph f of x equals 2x cubed plus 5x squared minus x minus 6. Now, when we do something like this, there are a few steps to graphing this. The first one is going to be to find all possible rational zeros. Okay. Once you do that, you want to find all of the zeros and the multiplicities. Now, notice that number one is just all the possible rational zeros. That's going to help you limit what you need in order to actually test for zeros using synthetic division. However, number two is actually find all the zeros. And yes, you can use what we did on number one, but honestly, one of the easiest way to do that is to just use the calculator, and it really does help. The next thing we're going to want to find is the y-intercept. And the last thing we're going to do is we're going to look at the end behavior. Now, remember, this is not the same thing as the behavior at the zero, which is determined by the multiplicity. Okay, the end behavior is as it goes to the left, which way is the function going? Is it going up to infinity or down to negative infinity? And as it goes to the right, is it going up to infinity or down to negative infinity? So let's see how we do this. Okay, so the first step here is going to be to find all the possible rational zeros. P in this problem is 6. Now remember, it's always the constant term is the p value, and the q value is always the leading coefficient. A lot of people get this confused because you think p divided by q, that, well, p should go first. Well, in the alphabet, yes it does, but here p is right here and q is right there. Or at least those are what we're looking for, the factors of those numbers. So the factors of 6 are 1 and 6 and 2 and 3. The factors of q are 1 and 2. So the factors of 2 are 1 and 2. So we're going to look at every single possible p divided by q. So we do 1 divided by 1, 1 divided by 2, then we go to the 2 here, then we do 2 divided by 1, 2 divided by 2, 3 divided by 1, 3 divided by 2, and then 6 divided by 1, and 6 divided by 2. Then we simplify. 1 divided by 1 is 1, 1 divided by 2 is a half. I'm going to go ahead and put plus or minus as we go along. 2 divided by 1 is 2. 2 divided by 2 is 1, but we already have it. 3 divided by 1 is 3. 3 divided by 2 is 3 halves. 6 divided by 1 is 6. And 6 divided by 2 is 3, but we already have that one. So this is going to list all of the possible rational zeros. Now remember, if a zero is an irrational number, it's not going to be listed here. In other words, if the square root of 2 is a 0, you won't see it here. It's just the way that it is. It's just the possible rational zeros. Okay, so these are all the possible rational zeros. And what I can do to go on to number 2 is I could just choose a number in here and use synthetic division to try and see if it's a 0. But that becomes a little bit tedious. So what we're going to do instead is we're going to use the calculator. Okay, so here is a graphing calculator. Let's quit and go to the home screen here. If you click on y equals, make sure you clear anything that's in there. I'm going to go ahead and graph what we have here. The 2x cubed plus 5x squared minus x minus 6. Now you do have to be a little bit careful here. Make sure you use the minus sign and not the negative, because if you put a negative right here or right here, the calculator is going to look at that as multiplication of a negative, not just subtraction. So you do have to be a little bit careful. And if the 2 out front was negative, you do have to use a negative instead of a subtraction sign. I know it's a little bit weird. Okay, so at this point, I'm going to press zoom 6 just to make sure I have the standard window. And, oh, fantastic, I can kind of see what's going on here. So what I'm going to do is I'm going to go to my table. Now, it's right here, so I'm going to press second graph, and that's going to take me to the table. Now, if you see some weird numbers over here, go to your second window right here, which is what it says table set. And the first number is the table start. In other words, it's what number you're going to see first on there, on the x value. So I'm going to put -5 just because, you know, random reasons. And then the delta table, that means just the change in the x value. Make sure that's 1. And you can make it, you know, a half if you want or something like that, but 1's probably the easiest. So if you press second table again, notice that it originally showed me -2 to begin with, so now it's showing me -5. Good. So if I look at the y values, a 0 is a 0 because the y value is a 0. So if you look here, this right here is a 0, so that means that the x value that corresponds with it, that -2, is a 0. But remember, we have to prove that it's a 0. You can't just say, oh, I know that all these are zeros because of the calculator. Sorry, it doesn't work that way. So take that -2 and prove it using synthetic division. So I have a 2, 5, -1, -6, bring down the 2, multiply, add, multiply, add, multiply, and add. Fantastic, I've just proven that it's a 0. And notice that we have 3 numbers here. And yes, this is a quadratic, in other words 2x squared plus x minus 1, plus x minus 3. I could set that equal to 0 and solve. That gives me my other 2 zeros. Or, if you look here, there's another 0. Notice that it's 1. So what I'm going to do is I'm just going to keep going here, put a 1 right here, and then just use synthetic division on these numbers right here. So bring down the 2, multiply, add, multiply, and add. Now, well, okay, we've just proven that this 1 is a 0 as well. Now we have 2 numbers. Now, because this is degree 0, that means that this is degree 1, so this is just a linear polynomial. So what I'm going to do is I'm going to take that 2x plus 3 and set it equal to 0 and solve. Subtract 3, divide by 2, so x is equal to -3/2. So what I've just done is I've shown that -2, 1, and -3/2 is a 0. So I'm going to make a small little table here, showing the 0, the multiplicity, and the behavior at that 0. Now we have 3 of these here. Okay, so this -2 is a 0, so put that there. And I'm going to try and make this in numerical order, so this -3/2 should go next, because that's -1.5, and then 1. Now, the multiplicity of each of these is 1, and a lot of people get confused as to why. Let me do something that is not actually happening just to show you what can happen. So instead of, let's say it wasn't 2 and 3 here, let's say it was 3 and 3. Or sorry, 3 and -3, how about that? Let's say you had 3x minus 3 equals 0. Well, you'll add 3, so that gives you 3x equals 3, and divide by 3, so x equals 1. So at this point, you'd have -2, 1, and 1 again. Notice that this 1 would be used twice at that point, and I wouldn't need any, I would only have 2 zeros. But the multiplicity for this 1 would be 2. That's how you can tell if you have a multiplicity greater than 1. Fantastic. Okay. So because of this, the multiplicity is 1 for all of these, and remember, if it's an odd multiplicity, it crosses at that x value. Good. The next thing we need is the y-intercept. Now, to get the y-intercept, it's actually pretty easy. The y-intercept, we just need f of 0. In other words, x is 0 for your y-intercept. So plug in 0 for all the x's, what are we left with? Well, we're left with -6. So the y-intercept is 0, -6. Fantastic. Now, the only thing we have left is the end behavior. What's the degree here? It's degree 3. Now, because it's degree 3, it either looks like this, or it looks like this. It's odd, and it's an odd degree. So it's either this or this. Now, because this 2 is positive, it's actually going to look like this. It's the first one. It'd only look like the other one if it was a negative leading coefficient. So the end behavior looks like this. Goes down to the left and up to the right. And at this point, we just graph the function. So we're going to want to put in all the zeros. -2, -3/2, and 1. Graph our y-intercept of 0, -6. 1, 2, 3, 1, 2, 3, 4, 5, 6. Right there. Good. And then graph your end behavior. After this last 0, the function should be going down to the left. Or sorry, after this first 0, it should be going down to the left. And to the right of the last 0, it should be going up to the right. There we go. It's a little bit better. Fantastic. Now, you just kind of realize that because you cross at each one of these zeros, if you're down here, you're going to be crossing up this way to the other side into quadrant 2. But at some point, it's going to have to come back down to this 0 here, and it's going to cross again. And it's going to go down through this point, and it's going to come back up through this point and cross to the other side as well. And at this point, we just kind of want to connect everything. Connect it, connect it, connect, and connect. Fantastic. Now, this is not an exact graph. I don't expect an exact graph. I expect to see correct zeros, the y-intercept, the end behavior, and the behavior at the zeros correct. Those are the important things. If I wanted to know exactly where this function turned back down to go back this way, then you would need calculus. And the same thing down here, where does it turn back up here? Or where there are some things called inflection points. Where are those? Again, that's a calculus question. So we're not going to be able to do this exactly, but we can get a general feel of the graph. Now let's bring up the actual graph here. So if I go back to the graph, this is what I see. Now over here it looks weird. So actually, if you wanted to, you could zoom in by doing zoom to enter, and you can see it a little bit easier right there. Okay. Again, I like the standard window, zoom 6. Alrighty. Well, I believe that's it for this question. Y'all have a great time, have fun, and I'll see you in the next video.